All right. So, not particularly interesting. How do we actually introduce some more details to our model? And Underworld functions are how we can do that. So they're kind of ubiquitous, I guess, throughout Underworld now is the function set. And they allow you you'll be using functions to define everything really, viscosity, diffusivities, whenever you want to do any analytics on your models, if you want to integrate over your domain, it's all going to be done through functions. So, they're really just it's really just designed to make dealing with your discrete objects straightforward, and fun, if possible, I guess. We want you to just be able to use them in a really natural way without having to, jump through hoops to get where you want to go. So we've got operator overloading, which allows you to, for things like addition, you could take two mesh variables, you can add them together, you could divide them, multiply them. We've got also, indexing operations, so you can grab a particular component off a vector field and so forth.
It's more like a calculator function or something in parallel. So if you're operating on the mesh.
Possibly, yeah. I'm not that familiar with it, but yeah. But it's not just for mesh; it's for everything. You can construct functions that don't. Well, and I'll show you an example that don't rely on any mesh or any discrete data at all. That's the idea, and then you can combine that with your mesh data. So basically, what you're doing with functions is in Python, you're constructing function templates. I mean, you don't need to worry about this. It's all under the hood. Just trying to get across a bit of what's actually happening. In Python, when you're using your functions, you're really just describing the function that's going to actually be evaluated later. And we do that for efficiency reasons, because when it comes to evaluation time, it all happens under the hood in C. Right? So it's not happening in Python, so it can really be done pretty fast. We kind of try and strike a good balance between efficiency and flexibility. And I think it does a reasonable job of that, actually. With functions, like I mentioned, all your analysis can be done with functions. Well, we've got functions that, for instance, you can use to define exceptions. So, if you've got a relatively complex function and, you're a bit concerned that it's your viscosity, but potentially it might end up negative somewhere, you can define a function which will catch that out and then will halt the simulation when you hit a negative viscosity. There's functions to do things for safe mathematics. So, if you could divide by 0, it'll halt your simulation and let you know that you've got to divide by 0. All sorts of things. Also got view functions, which allow you to look at the function data as it's being evaluated effectively. So it doesn't modify the data, but it just records some metric relating to the data, like the magnitude, maximum values that have been encountered. And you also do things like pass in two other functions and ask it to always return the minimum of those two functions evaluates. Do lots of things. I'll point out that Underworld functions are not the same as Python functions. So, for instance, if you want to use a tangent function, you would have to make sure that you use our tangent function, not the one that's in the math.tan or the Python maths module. So, let's just grab a shortcut. All right, I mentioned that mesh variables are functions. So in Python, you've got this instance function which basically just checks an object and checks what type it is. So if we do, let's say our temperature guy, and we can do function is the abstract class. It's true. The temperature variable is itself a function. Right. So let's create a new variable. What do we want to do here? So now we can do new variable dot data. Let's, I think what I do in the example. So I think this new notation. Right, so this is basically NumPy's notation for grabbing for a strided data. So we grab every third item, we're setting to a value of 1. Let's do. Let's have a look at the one we just created there. Right. And so forth. Right, so I want to demonstrate operator overloading. So we can just do that directly here. Actually, we don't even need to do that. So in this instance, we're going to fire this plus operator overload. It's going to create a new function and return that, and then go ahead and render it. So I can rip that out, actually. Let's just rip that out for now to make this. This. Same thing, of course, you can subtract, divide. I'm not sure if I want to do that. No. All right, so I didn't like that because we got to divide by 0 in there. I did mention that we can add the safe math. There's a way to make to catch these things out. So we can just do function dot exceptions, safe maths. So now we're wrapping that whole thing with a safe maths function, which is basically going to check out for things like divide by zeros or just not valid numbers, right? Let's see if it does the job. Right, so now it's telling us divide by 0 encountered while evaluating the function. And I think you can do things like, to the power. Right. So on the cheat sheets, I've given a quick overview of the various functions, different function modules, but yeah, let's have a quick play with some more of those. So for instance, inside the maths module, again, autocomplete, you've got all your standard trigonometric functions there. So do something like this. All right. Take an exponent of it. I think you get the idea. So when it comes to defining a rheology, hopefully it's very straightforward. So let's try and define that guy. All right. So let's say e to naught is equal to whatever. Some activation energy. Well, doesn't really matter what we're going to set it to. Now we can set our eta function equal to eta naught times function. Again, we use our own functions here. Math.exponential of e divided by. Now, this is where we plug in our temperature variable, plus 1. Right, this is going to fail. Well, it's going to fail, but that's not what I was looking for. This is the failure I was looking for. Right. One thing you just need to be careful with when you're using functions is that you need to be careful with the types you're passing in. In this case, the issue was with this 1 here, because under the hood that gets converted into an integer type. Right? Now, actually, we don't want it to be an integer type. We want it to be a float type. All right, so if we just do point there, now it's actually a floating point Python object. Therefore, our function will convert it into, under the hood, into a floating point constant function. And therefore, the operator, in this case, the addition operator will work. So it says here, the operator add does not, when you're adding it, it expects both the operands to be of type double. So that's one place you just have to be a bit careful, and people often get caught out on that because the error message itself is a little bit obtuse. Just a quick overview of what's happening here again. We've got this overload here. This eta naught is simply the value of this. This is under the hood going to be converted into a constant function, and then it's going to be use the multiplication overload. It's going to multiply by exponent, and here again it's all largely operator overloading with the division and the addition. The idea is that the syntax you type in is as close as possible to the equations you're dealing with. So let's try now. Right. Any questions on that one? Yeah?
If you use the temperature bar in this equation, is this actually a reference to the field? So in case you have a time-dependent solution, it would like update the...
Yep, definitely. Yep. Yep, so right, if I come here now, I'm not going to modify the function. I'm just going to change the temperature variable itself. Let's say 5 is equal to this variable, right? I've got to add this data guy. Well, I'm not seeing anything. I'm not exactly sure if we're setting anything. Do you want to have multiple concurrent views or visualizations? Not so much, no. I mean, it's functionality it's functionality that we used to have, but we've kind of moved away from. Well, actually, I think you can you can't directly with glucifer, but I think in Python, if I'm not mistaken, you can ask it to.
You can import matplotlib if you can do it in matplotlib.
Yeah, well, you could definitely do it in matplotlib, but I think even in the notebooks itself, I can't remember the syntax for it, but you can actually...
That's true. When there's multiple ways to do it.
Yeah.
You can save the images.
Well, you can save the images, but there's a way in the notebooks itself to not need to save the images and ask it to draw a few images at one time.
That's right, but you've got to create the images.
No, you don't actually need to create... We don't need to save it to disk.
You've got to take them out of glucifer.
Hmm?
You've got to take them out of glucifer.
You don't actually need to store it on disk to do that. Actually, if that's what you're thinking. Now, there's a way you can do it directly in notebooks, and it will just render just through the show method there, and you can ask it to show multiple figures. It's not a glucifer function. It's a function in the notebooks itself. It's a way that notebooks can deal with when you return a IPython image object, you can return multiple IPython image objects.
Yeah,
There's a way to do it,
the
but
IPython image object
yeah, I can't remember that bit. But
you always say that.
our visualization guy, Owen, he was showing me that recently. Yeah.